A new era in the science of astronomy has emerged. Advanced instruments in space now reveal a universe that is constantly changing with terrifying interactions. Astronomers in distant galaxies have witnessed space and time being shredded by explosions so immense that conceiving them unsettles the mind. But what could produce such an extraordinary force? Whatever it is, it sits at the center of our Milky Way. Scientists now believe it is the largest and most powerful object in the cosmos, yet it emits no light. This object is called a black hole. The black hole was first introduced by Einstein's equations, at a point when space and time are tightly bound together. But great scientists believed that the existence of such a thing in nature was never possible. Yet something very strange and powerful lurks at the center of our galaxy, whose existence was first confirmed 75 years ago. Radio telescopes recorded a hissing sound, like the hiss of steam. Astronomers know that the centers of other galaxies are densely packed with stars, but when they tried to see the stars at the center of our galaxy, those stars were hidden behind a thick curtain of dust. However, a type of light that we cannot see can pass through this dust. For example, infrared radiation travels with longer wavelengths. Welcome to the strange world of physics, where space and time are literally poured into a bowl. Space itself, the place, falls into the black hole. Think of it like a river falling down a waterfall into a gorge. Stars are like rowboats, struggling to pull themselves upstream, but they are inevitably dragged toward the center of the black hole. Gravity becomes a noose. The closer you get, the tighter the pressure and the noose becomes, until you reach the horizon, the point of no return. Despite all its mystery, the black hole is the product of stars themselves and their immense gravitational forces. Their angel of death is a star known as a red giant. This star is 10 times heavier than our Sun, yet it burns out in just a fraction of the Sun's lifetime. Deep within it, the pressure of gravity raises the temperature to 1 billion degrees. Helium and carbon fuse into heavier elements, oxygen, silicon, and sulfur. Then the star collapses under the weight of its own enormous gravity, sending a shock wave outward. After an extreme compression, it explodes in a cataclysmic blast known as a supernova. What remains is a dense core made of subatomic particles. This is a neutron star, with a diameter of less than 16 kilometers. It is so dense that a teaspoon of neutron star material would weigh about 1 billion tons. Eventually, its gravitational pull grows so strong that even the star itself collapses in on itself, with nothing able to stop the fall. A black hole is born. Its density is 1 million times greater than Earth's, yet it is so compressed that it effectively exits the world as we know it. We know exactly what a black hole does to its surroundings, to the neighboring stars, to the gas that drifts too close. The Milky Way is a giant ring containing more than 100 billion stars. Our Sun lies roughly in the middle of this ring. Finding the black hole at the center of our galaxy depends on observing the stars that orbit around it. The first step was to determine how large this object is, and by measuring its gravitational pull, to calculate its mass. Scientists in Europe and America confirmed the existence of the black hole without ever seeing it directly. For us, sitting in a quiet corner of the galaxy, it's hard to imagine the violent events at the center. The closer you move toward that core, the denser it becomes. Astronomers call this central, star-filled region the bulge. Entering the bulge is like driving onto a cosmic highway during rush hour. It is packed with stars, all moving at tremendous speeds in every direction. This region is always in a state of heavy traffic. The black hole is surrounded by a cloud of extremely hot, falling gas. The space around this point is so warped that it bends the light passing nearby. And yet, the gravity of a supermassive black hole is so vast that it might be possible for you to fall inside and still survive, at least for a moment. Now, thanks to computer simulations, we can visualize Einstein's equations. As matter moves toward the core of a black hole, it encounters a horizon, a vast wall of compressed energy. But this is not the end of the journey. The simulation can be paused, and return to the strange predictions of Einstein's equations. A passageway appears. A tunnel through space and time, known as a wormhole. And now we pass through a peculiar opening, called a white hole. Here, the overwhelming, whirlpool-like gravity is reversed. Instead of pulling matter inward, it blasts it outward into distant regions of space and time. But where does it lead? In science fiction stories, a wormhole is always an escape route to somewhere else. But in reality, the interior of a black hole is likely so chaotic that the creation of a wormhole would be impossible. The black hole at the center of the Milky Way is already a strange phenomenon in itself. But is it ordinary, or is our galaxy truly an exceptional wonder of nature? Astronomers have mobilized to find the answer, launching a major project to discover other supermassive black holes. They began their search in a region of New Mexico, exploring galaxies more than 1 billion light-years away from Earth. In steel plates, they drilled tiny holes that matched the exact positions of galaxies in the night sky. Then, they inserted fiber optic sensors into those holes. For the first time, astronomers could capture the light of hundreds of galaxies at night. They were searching for a specific signal, a mark that comes from the core of a galaxy, the glow of hot gas spiraling toward a black hole. This project is called the Sloan Digital Sky Survey. Its goal is to map the entire northern sky and to uncover the arrangement of galaxies across the cosmos. Out of the 125 billion galaxies visible to us, more than 1 million have already been studied. The larger galaxies, marked with red circles, each contain a supermassive black hole at their center. But how is it that so many of the universe's giant galaxies harbor such colossal black holes? To find the answer, we must return to the very beginning, the Big Bang. With the expansion of the universe, matter and energy were flung outward at incredible speeds. Over billions of years, gravity transformed the cosmos into vast whirlpools of gas and galaxies. Within this immense network, gravity drew together the great clouds of primordial gas. Over tens of millions of years, hydrogen clouds merged, growing denser and denser. Some became so hot that they ignited. The very first stars, the giants, were born. These giants were hundreds of times larger than our Sun. They burned rapidly and exploded in brilliant flashes of supernovae. Billions of years later, a satellite called SWIFT was placed in orbit to detect the light from these explosions. SWIFT became the eye of an international team of astronomers. By studying these signals, they uncovered one of the most important clues to the formation of black holes. The most distant examples belong to the earliest generations of these cosmic monsters. This computer simulation reveals how our Milky Way galaxy was born. Over billions of years, the Milky Way grew from violent collisions and mergers of smaller galaxies. In this cosmic dance, galaxies swirled around one another, their gravity pulling them ever closer. When one galaxy came near, each could feel the other's pull. The Milky Way began as a graceful spiral of orbiting stars, but slowly transformed into a colossal vortex. Black holes and galactic centers grew larger as they consumed one another and merged. Quasars, the brilliant beacons at the hearts of distant galaxies, are powered by such feeding black holes. Here, black holes devouring matter shine brighter than anything else in the universe. The Hubble Space Telescope captured images of a dormant quasar in a nearby galaxy known as M87. In its very small central region, Hubble found gas heated to tens of millions of degrees, swirling at millions of kilometers per hour under the force of gravity. These clusters are the product of galactic mergers, on a cosmic scale. This computer simulation shows how a galactic cluster moves within a region spanning tens of millions of kilometers. Hundreds of galaxies take shape, then gather around a common center. The central galaxy consumes them, growing ever larger, and with it, so does its black hole. But how can a black hole, a terrifying monster that swallows everything, release energy back into space? A whirlpool of matter, spinning at tremendous speed around a black hole, generates an immense magnetic field. This field hurls vast amounts of gas outward, creating a powerful engine of matter whose force is hundreds of millions of times greater than that of our Sun. The energy shoots straight out across the galaxy. These cosmic engines can literally sterilize galaxies, halting the birth of new stars. And yet, in smaller galaxies, such black hole outbursts may play a creative role. Their shock waves eject heavy elements formed at galactic centers, seeding the cosmos with the ingredients needed to build solar systems. The monster of the Milky Way may even have helped in the formation of our own solar system. But what could prevent us from being swallowed by it? Everything depends on the diet of this monster. Our black hole has likely stopped feeding for many years. However, in 1999, the Chandra Space Telescope detected a powerful signal from the center of the galaxy, an explosion just outside the event horizon. This blast kept research teams awake for days. These scientists hope that, one day, not far in the future, they will be able to see the monster directly. By linking observatories around the world into a giant telescope capable of peering deep into the galactic center, they aim to observe what lies within. What they expect to see is a dark ring framed by sparks of light. Against the backdrop of its past massive eruptions, these sparks are mere flashes. But what does the Milky Way's monster need to awaken? Could these energy engines form again across the galaxy? Observations continue from Earth's surface. Astronomers have traveled to the South Pole to capture radio signals from the galactic center. They can detect signs of a disaster in the making. A massive ring of gas is forming just beyond the central black hole of the Milky Way. Over time, this vortex will accumulate a mass equivalent to 300 million suns. When this outer ring reaches a critical point, it begins feeding into a second, inner ring, orbiting closer to the galactic center. The inner ring condenses into a massive cloud, within which a storm of new stars will be born. Then, the gas cloud starts spiraling into the black hole's maw. Once the black hole begins feeding, its eruptions will be visible even from galaxies far beyond our own. The Milky Way will survive this episode of black hole activity. But its chances of surviving the next cosmic threat are slim. This threat is a galactic merger. Even now, the end of our galaxy approaches. Our colossal neighbor, the Andromeda galaxy, is hurtling toward us. By knowing the trajectory and the gravitational force of this galaxy, scientists can predict the consequences of this cosmic collision. Initially, the galaxies will twist around one another, attempting to tear each other apart. Imagine the view from within the Milky Way, two beautiful, spinning galaxies gradually moving toward each other. They will lose their original shapes, forming a new void into which stars and gas will spiral, feeding the newly reborn cosmic monster. This collision will fling clouds of stars and gas billions of kilometers into space. Some of this material will be shot toward the center of the new galaxy, causing even more spectacular explosions. In this chaos, our galaxy will either be flung into the emptiness of space or fall into the mouth of a black hole. The Milky Way will be destroyed, but what will become of its central black hole? This black hole will join another quasar. Stars and galaxies come and go, but supermassive black holes always grow larger. Once considered cosmic curiosities, black holes may be the natural products of a turbulent universe. This monster currently rests in quiet slumber, but how long will it be before we witness the rise of the Milky Way's monster once again?